Hi guys, so today you're going to start your roller coaster design. Remember, it's an individual assignment. However, you can work with someone, but you must have your own unique roller coaster. So make sure you read through all the criteria, and I just wanted to make a couple of suggestions. So first, you should just design some kind of polynomial that you want to represent your roller coaster. So you can draw something like this, where I'm going up, I'm going down through a tunnel, coming back up, coming back down, or you can draw it something like this. But either way, draw some kind of a design. Then come up with your formula based on what you know about polynomial functions. So for example, remember our x-axis is our time in seconds. That makes the most sense for a roller coaster. And our y-axis is the height. And so I would let each x equal 10 seconds. So for example, if x is 1, that's 10 seconds. 3 is 30 seconds, and so on. And so right here, I know I have a 0 at 0. And so my factor would just be x. It's going straight through, so it's x to the first power. Here, I want to say all this happens about 20 seconds later, so I'll call that 2. And so I have x minus 2, but notice I'm lingering, I'm going down. And so it's a linger, so it's 3, multiplicity 3. And then I want to say this happens maybe another 10 seconds later, so this is 3. So I have x minus 3 to the first power because it's straight through. And then, I don't know, let's say this is 5. But notice it's bouncing. And so I have x minus 5 squared. So I have my polynomial function. But now let's see. What's the degree of this? Well, I have 3, 4, 5, 6, 7, 8. And it's positive 8. 2, 3, 4, 5, 6, 7, 7. It's positive 7, so my end behavior looks good. I'm coming from below and I'm ending above. But obviously my roller coaster can't come from negative infinity and finish at positive infinity, so you need a domain for your roller coaster function. So x, or maybe better t, has to be between, well, where do you get on a roller coaster when time is 0? And I'm ending my roller coaster, well, I'm not going to end up here, but in this case, I think I'm going to end when I come back down to the ground, or maybe I'm going to end over here. Let's say it's 6 in this case. So I'm going to say somewhere less than 6. I can end on a platform, that makes sense. You might want to end on the ground. You can end at any point that makes sense, either a platform that's of a height that you would expect people to walk up and down, or on the ground level. So be aware of your domain. Now the other thing is your polynomial function must match your graph. However, look at these relative extremas. Now these guys are a little bit harder to control. And so what you are required to do is, based on your polynomial function, you do have to tell me exactly what all your relative extrema are, the exact numbers. When we transfer this to poster paper, you're then going to scale it down and let me know what a more realistic height would be. So let's get started today. You will continue this tomorrow when I will be here. Have fun.